Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to see the motion in a plane. Okay, before we have covered vector chapter already, but now here onwards we are going to see the applications of motion in a plane, like a projectile motion, circular motion, relative velocity and its applications. Okay, so in this video, under the first application we are going to start projectile motion and especially the ground to ground projectile motion. After that, in further videos we will see other projectile motion also, okay, like horizontal projectile motion, inclined projectile motion if it required. Is it? So let's start the video. So as I have told you very well, projectile motion is the example of a motion in a plane. So first we will understand in which situation the body will do the motion in plane, that means motion in two dimension. Okay, so let's see here. When a body is projected such that its velocity of projection neither parallel nor anti-parallel to the acceleration. Again I am telling, neither parallel nor anti-parallel to the acceleration. That means theta should not be 0 degree, it should not be 180 degree. Then the body moves along a curved path here. Okay, so angle between velocity and acceleration should not be 0, should not be 180 degree. Then only the body will move along a which path? A curved path, 2D path. Okay, this motion is called two-dimensional or 2D motion here. Is it? After that, even same concept will be applicable for the 3D motion also. Okay, now after that, see, if acceleration acting on the body is constant, now acceleration can be variable also, it can be constant also. See, if acceleration acting on the body is constant value, that means uniform acceleration, then the curved path of the body will be parabolic. Which path? Constant acceleration and velocity and acceleration, they are not making 0 degree or 180 degree. In that situation, the curved path will be which one? Parabolic. Okay, and this motion is studied under the projectile motion. Okay, so here I am going to just show you here. Let's take here I have taken this projectile motion. Projectile motion, what happens that here, like example of the projectile motion, a cricketer has hit the six or a footballer is hitting the goal, or we are throwing any stone and all, not vertically direction, by making some angle. Then the path of the projectile will be, that means the path will be which one? Parabolic path, or we can tell projectile motion when acceleration is the constant. Okay, so see here, if I talk about the acceleration at different points, you know very well here, this gravity downward. At different points I am taking, see here also, see this gravity is at all the points, what is happening that here? This gravity is downward direction, because you know very well, gravity acts in a which direction? Towards the center of the earth, or we can tell vertically downward direction, like this here. Is it? Let's take this is point O, this is point A, this is point, wait. Now I will take here, whenever I will draw the graph, I will always use this points only. This is O, this is P, let's take this is A, this is Q, and let's take this is B here. Okay, and if I talk about draw here the velocity at different points, so see here velocity will be like this. Is it? Tangent you have to draw here. Here velocity will be like this, tangent. Here velocity will be like this. Here velocity will be like this, and here also like this. Is it? So remember that here, if in case we are throwing with speed u in the absence of air, then it will hit the ground also with speed u. Velocity is different because direction is different, but speed will be same. Okay, and if I talk about here the angles, so let's take for example, what is this? This angle is theta. So what will happen that here, by symmetry, this angle will be also theta. Is it? And this angle how much here? You know very well, this angle is 90 degree here. Now we can tell here even phi equal to 90 degree. Here you can see angle, here you can see angle. Let's take this angle is here alpha. Okay, and here what I will take here, let's take here in this situation, this angle is beta here. Is it? So you can see here in all this what is happening that here velocity and acceleration, they are not at all parallel or anti-parallel. They are making some different angles here. Okay, even here also I can write here, let's take here velocity is Vp, here velocity is Vq, and here velocity is Va. Okay, so here you can see very well velocity and acceleration, they are not parallel or neither parallel nor anti-parallel. Different is there, and at all the places what is this? This gravity is constant. That's why this is which motion? This is the, again I am telling, this is which motion? Projectile motion. And projectile motion is having which path? Projectile motion is having the parabolic path is there. Is it? So points should be very clear and the velocity directions and all should be very clear. At the highest point, vertical component of the velocity will be 0. So only the projectile. What I'm telling that a body or object, whatever we are throwing, that is called even projectile. So what I'm telling, at the highest point, vertical component of the velocity will be 0 and kinetic energy will be minimum. All these things we will learn. That's not a problem. Okay. So I think so. This is very, very clear to you. Okay. Next one, let's see here. Now we are learning just basics. So see here. In projectile motion, body will move in horizontal as well as in vertical direction simultaneously, which are independent from each other. Hence, we can say what we can say. We can say that projectile motion is the superposition of the horizontal motion plus vertical motion here. Okay. So here this is the projectile motion, parabolic path. If I write here, this is the combination of the horizontal motion. See here, the horizontal motion is happening plus vertical motion. Vertical motion, how to write here? Vertical motion we used to draw like this here. Is it like this here? It will go up and then it will go down. Actually, this will horizontal motion. This is which one? Vertical motion. Just a representation. And both are mutually perpendicular. So here what will happen that here, if I write, here we can write the equations like vector v equal to vector u plus vector at. Now, because this is which one? 2D. Or if I write here the equation, second equation, vector s equal to vector ut plus half vector at square here. Is it? Because here this is the 2D motion, we can use this one here. Okay. But writing equations again and again in a vector form, it will be somewhat complicated. So what we'll do here, we will divide into the two parts, horizontal motion and vertical motion. And sign convention, if I'm not telling anything, basic sign convention will be followed like this, mathematical sign convention, plus minus, upward plus, downward minus. Wherever I forget to tell the sign convention, this sign convention will be there. Okay. And if I write here the equations, what will be the equation here? See, along x direction we can write vx equal to ux plus ax into t. Now this is one equation, and sx equal to uxt plus half axt square. Okay, this is along the horizontal direction. Similarly, along the vertical direction, what will happen that you see? Vy equal to uy plus ay into t, and you can write here sy equal to uyt plus half ayt square. And x and y will not mix up. That's why we can tell that here this projectile motion is a superposition of the two motions. That means this 2D motion is the superposition of two 1D motions here. Okay. So I think so, students, this is the very, very clear to you, this basic. Is it? After that, now we'll move to the next one. See here now, ground to ground projectile motion. So ground to ground projectile motion, what is there? We are throwing with the ground and it is hitting the ground here. And remember that here, this is called the projection point here, highest point, and this is the landing point here. Okay. So projection point is O, and highest point I will write here with the letter A, highest point, and this is the landing point B. Okay. Remember that here in middle I will take some other points also, P and Q also. No, body is going like this. No, we have thrown like this. Good. Okay. So remember that here again. So here, if the body is projected with time t equal to 0, you can see O to A, the bodies keep on going up. So the time taken to move from O to A will be called here the time of ascent. Is it? A to B will be called the time of descent, or we can tell here the total time will be TA plus TD. I am just telling the basics, capital T here. Okay. And this will be the maximum height. What will be this here? This will be the maximum height here. This one I am writing here now. This will be the maximum height, and this will be called here the horizontal range. What is called here, students? This is called here the horizontal range. This is the horizontal range. See this here, right? And I will change here the color. See, this is called here the horizontal range here. Now this is the basic things are there. Okay. So now see, let an object be projected from origin at t equal to 0 with initial speed u, making angle theta from x-axis as shown in diagram here. Okay. So here diagram is here. Now if I write here, I have told you very well what is the maximum height h. That means from here to this maximum height, this is time of ascent, time of descent, total TA plus TD, capital phi, and this is the capital T, and this is here capital R, horizontal range. So now what will happen that here? Now we will follow this. We are going to resolve the velocities now. Okay. So let's take here the body is projected with velocity u, or we can tell speed u, making how much angle? Making angle theta. So remember that here, when we are throwing with speed u in absence of air, I am not telling anything, that means in absence of air, if we are throwing with speed u, what will happen that here? It will hit the ground also with speed u. Speed u will not change here, okay? Maybe you can see direction is different, but direction is different, velocity is different, but speed will be same, okay? So here u is there. After that, if I talk about at point P, let's take here I have taken the velocity Vp, okay, and here I have taken here the velocity Vq, and at the highest point, what is happening that here? Velocity Va, is it? So all these things are there, and points I have told you very well, O, A, B, P and Q, is it? Now after that, students, we will just resolve here, because what we are going to see, when we resolve velocity and acceleration along x and y directions, we get, okay, so we are going to resolve here. So when we'll resolve here, kindly see resolving. Resolving means what will happen that here? We'll follow here the parallelogram method, is it? So this side component will be what? This will be u cos theta. Mathematical sign convention, okay? And this will be what here? This will be u sin theta. Is it? Upward plus downward minus. Right side plus left side minus. Is it? So u cos theta, u sin theta. Here if I resolve here, see here, this will be called here Vpx along x direction. This will be called here Vpy. Is it? After that, similarly here also if I resolve here, see this side is called here Vqx and downward it is called here what is, just like a parallelogram should be there, okay, it's like a parallelogram. This will be called here Vqy, and again I am writing the sign convention, confusion should not be there, mathematical sign convention, plus minus, and here this plus this minus here, is it? So what we can tell here, students, two sides we can make. This is from O to this is the time of ascent. In this situation, what is happening that you can see very well, the vertical velocity is upward and acceleration ay will be downward direction. Even we can write here minus g, and velocity will be in this direction. So you can see very well v and a in opposite direction. From O to A, what will happen that here? Vertical component of the velocity will decrease. At the highest point, it will become 0. Then after that, see, I am talking about the vertical component. Here what will happen that here? From A to B, that means during coming downward, what will happen? The velocity will be downward, and see the gravity will be also downward here. Is it? I can write here, see ay is a minus g here. So what will happen that here, students, here? A to B, the vertical component of the velocity will increase, okay? But horizontal component of the velocity will be always constant, that will see that. Why? Because gravity is acting in which direction? Downward direction. Is there any acceleration? Along x direction, no acceleration, because we are considering the charged particle is neutral. No charged particle, no electric field and all this there, okay? So if I talk about here, in this direction, there is no acceleration. Ax is 0, okay? So this gravity will only affect vertical component of the velocity. Horizontal component of the velocity will be what? It will be intact here, okay? And see this one like this here, is it? Great. And here, see, it should be like a parallelogram here, no? It should be like a parallelogram at all the points, like this. It should be like a parallelogram, somewhat at least it should maintain, is it? Like this should be there, is it? And here also, if I resolve here the velocities here, students, see here also, see this side component, it will be u cos theta, and downward this component will be what here? U sin theta, and here also parallelogram should be there, okay? So you can see we have resolved the velocities. So now we are going to write here the velocities here, okay? So see what is given here, it is the velocity at different points. At point O, you can see very well what is the horizontal component of the velocity. Ux is u cos theta. What is the vertical component of the velocity? Uy means u sin theta. Is it? Say this side here, this is u cos theta, ux, this one will tell ux, and this one will tell here uy here, okay? Horizontal component, vertical component. See here also I will write here, no? This here, all this I will write here, no? So now let's see here after that here, at point P, what we can write here? Angle. Let me make here the angle also. Let's take this angle is alpha, okay? And by similarity, actually this angle will be also alpha only, okay? So see right here, I am writing here alpha, no? Theta, alpha, here also alpha we can write here, okay? So Vpx will be Vp cos alpha, Vpy will be Vp sin alpha. Here Vpx will be, Vqx will be Vq cos alpha, Vqy will be minus Vq sin alpha. Why? Because downward negative is there. Similarly here ux will be u cos theta, ui will be minus u sin theta, okay? All this I am going to write now here, okay? So this one we have written that here, now Vq, u cos theta, uy, u sin theta at point O. Now at point P, what is here? See, this Vpx will be Vp cos alpha, okay? And this Vpy will be what here? Vp sine alpha. Okay. Similarly, at point A, if I write here at point A, Vax, there is no acceleration along the x direction, so horizontal component of the velocity will be same, u cos theta only. Remember that here. Even I can write Vax equal to, I can write here Va cos, cos 0, or okay. Vx will be how much here? U cos theta, correct only now. And Vay will be how much here? This will be 0, is it? 0, because at the highest point, vertical component of the velocity, how much here? 0. Then at point Q, what will happen that you see? Vqx will be Vq cos alpha, okay, and this Vqy will be minus Vq sin alpha, because in which direction? Downward direction. Here, at point B, again, this ux will be u cos theta, and this uy will be what? Minus u sin theta, is it? We have just resolved the velocities and we have written here, okay, and especially this one is very, very important. At the highest point, maximum, at the highest point, horizontal velocity, u cos theta, and here how much here? Vay 0. And remember that here at all points, even at all points, remember that here this horizontal velocity will be u cos theta. Why? Because ax is 0. There is no acceleration along x direction. This velocity will be always, whatever component you are writing, just make it equal to u cos theta. Okay, great. Now students, after that, acceleration, if we talk about here at different points here now. So acceleration, even any point is there. Let's take at point O, okay, vertical component only. Or if we talk about here at point P, or if we talk about here at point A, or we talk about here at point Q, or we talk about here at point B. So O, P, A, Q, Y. At all the points, this acceleration is going to be how much here? Minus g here, okay, vertical component. And at any point, if you take here, now any point you take here, horizontal component APX, or I write here AAX, or I write here AQX, or I write here ABX. At all these points, even what will happen? The horizontal component of the velocity will be 0. Is it? So, can you see here? Now, students, after that, we are going to see this horizontal and components of the velocity. Whatever I have told you, that we have written here. See, horizontal and vertical component of the velocity. See, as there is no acceleration along horizontal direction, see, horizontal component of the velocity, that means u cos theta, remains constant, as I have told you very well now, because ax is 0. See, similarly, as there is acceleration a equal to minus g along vertical direction, then vertical component of the velocity, that means u sin theta, decreases from O to A. Why O to A? That means from projection to the highest point. Why decreases? Because velocity upward, but acceleration downward. Then becomes 0 at A, vertical component, and increases from A to B. Why it is increasing? Because from A to B, that means highest point to the landing point, V and A both in which direction? Same direction here, is it? So this basic is here, okay. Now students, let's move to the next one here. Here you can see here, no, this table is there. These points are there, O to A to B, B. Horizontal velocity, vertical velocity, resultant velocity here, okay. So horizontal velocity at any point, generally I can write here Vx. Vertical velocity at any point, I can write here Vy. And you know very well, Vx and Vy is making how much angle? 90 degree. So resultant velocity from Pythagoras theorem, I can write here Vx square plus Vy square, okay. So now at all the points, horizontal velocity, how much here? U cos theta. Now because horizontal component of the velocity is what? It is constant U cos theta, is it? Now after that, if we talk about the vertical component of the velocity, here, what is this? U sin theta at point O, and at point B, how much here? Minus U sin theta, no? Because opposite direction is there. Now O to A, what is happening? Vertical component of the velocity, students, O to A, it is decreasing. Now what is happening that here? It is decreasing. After that here, A to B, what is happening that here? A to B, it is increasing, okay, increasing. And exactly at point A, what is happening that here? Vertical component of the velocity will become 0, okay. So if I talk about here resultant velocity, if I combine both of them, now resultant velocity, or we can tell magnitude of resultant velocity. So here what will come here? See here U, and here also the magnitude here. Now just use this formula U, and here this constant, this is decreasing. So what will happen that here? It will be decreasing. Now resultant velocity also decreasing. This will what happen that here? It will be increasing here. Is it? Remember that here. How at different positions the things are happening. Okay, and at point specifically A, this is u cos theta, this is 0, and this will be u cos theta. Okay, remember that here. Now students, let's solve this question. The question is what? See, the question is, at the top of the trajectory of a projectile, the directions of its velocity and acceleration are. Okay, so as you know very well, at top is here. That means at point, you know, velocity is the horizontal, only horizontal component is there, u cos theta, is it? And gravity, that means gravity acceleration, in which direction? Downward direction here, is it? So they are making how much angle? You can see very well, very important, 90 degrees. So what is happening that? They are perpendicular to each other at the highest point here. Okay, and here this u is there, theta is there, that is always understood. Okay. Next one, let's say here, this is the question. The question is what? See, the velocity of a projectile at the initial point A is 2i cap plus 3j cap. Its velocity at point B is how much here? Okay. So what is the question? Here they are taking this is point A, and here they are taking this is point B, is it? So at point A, what is given? 2i cap plus 3j cap here. Okay, 2i cap plus 3j cap. So let me draw here, see. This is given, what is this? 2i cap plus 3j cap, is it? So if I resolve here the components, this is the 2, or we can write a 2i cap, okay? And this is how much here? This is 3. This is 3, is it? So 2i cap plus 3j cap. Now after that, if I talk about here when it will strike, it will be like this here, okay? So here what will be there? Horizontal component is constant, anyhow 2, and this will be in which direction? Reverse direction, minus 3. Here upward plus 3, downward minus 3. So here I can write as see 2i cap minus 3j cap here, okay? Remember later, angle is all same. If here angle theta, here also angle theta, is it? So 2i cap minus 3j cap, no? So see, 2i cap minus 3j cap. Where is the 2i cap minus 3j cap? The correct answer is here, option C is the answer, okay? 2i cap minus 3j cap here, is it? Now students, let's see here this question. The speed of a projectile at its maximum height is half of its initial speed. The angle of projection is how much here? Okay, so let's take here, we are throwing with speed u, making angle theta, is it? And at the highest point, what is happening that here? Only horizontal component, that means what is happening? U cos theta, is it? So in the question, what they are telling that? They are telling that at the highest point, this speed is half of the initial speed. So half into u. So both the sides, u and u is cancel, is it? So we can write here cos theta is equal to 1 by 2, is it? That means theta, how much are the students? This theta will come here 60 degree. What theta is coming here, the students? Can you see very well? The theta is coming here, the 60 degree here, is it? Great. Now students, let's see some important points are there, like change in momentum, kinetic energy, time of ascent, time of descent, time of flight, or maximum height, horizontal range. So many important terms are there, but in this video we are just going to see change in momentum cases and kinetic energy cases, because in this video we are not writing the projectile equations. In next video we will write the projectile equation, then all other things we will cover. Here only change in momentum cases. Okay, so see here under the important term, first one, change in momentum, and momentum is the which quantity? Vector quantity. Okay, so see, this is O. Let me write here, this is which point? Always which point I used to take here? P. This is Q, here A, and here I used to take here B. Okay, so what we are going to do here? First we are going to write here the velocities here. Okay, so you know very well here, only will write here, see, this is u, angle is theta. Again it will strike with u, angle is theta, is it? And at the highest point, what is here? U cos theta here, is it? So students, if I resolve also, you know very well, this side component, what is this? U cos theta, and this side component. This side component is what? U sin theta, is it? Similarly here also what is this? U cos theta, okay? And this component, if I write here, this will be how much here? Minus u sin theta, if I take the direction downward minus, is it? So students, let me write here the velocities at different point. Okay, so let me write here the vector quantity. So velocity at point O is given by, what can I write here? See, u cos theta plus u sin theta j cap here, is it? See this one here. If I talk about at point A, it will be u cos theta I cap plus 0, because there is no vertical component of the velocity. Now, after that, if I talk about at point B even, okay, so at point B, what will come here? See, u cos theta I cap minus u sine theta j cap. Okay, these are the velocities we know very well here, is it? Now see, first case what is given? The first case is here, the change in momentum between projection O and highest point A, is it? So change in momentum means between projection and the highest point. So PA minus P naught. What is this? Highest point is A, projection point. Your change in momentum is final minus initial. So PA minus P naught. So what we can write here? See M, it will become here UA minus U naught. What is coming here? UA minus U naught here. Is it, students? So when you will do UA minus U naught, U cos theta I cap, U cos theta I cap will cancel out here. It will come here, see, M minus U sine theta j cap here. Okay, you just subtract it, you will get here. Now, if I talk about here the magnitude will come here, mod PA minus P naught, it will come here just MU sine theta. Okay, remember that here, what will come here? MU sine theta. You have to just subtract it. Okay, great. Now students, after that here, change in momentum between highest point O and the landing point B here. Okay, so here we can write here, see, PB minus P naught. PB means we can write here, see, M UB minus U naught here. Okay, so this is M. Now let's see UB minus U naught here. See, this is UB and this minus U naught. Okay, so UB, wait, let me see. Okay, so see, highest point and the landing point is there. Highest point is which point here? No? Highest point is which point here? Highest point is actually highest point is A, na? Highest point is A, na? So here mistake is happening. That's why I was thinking here. Highest point and the landing point is there. Okay, so just let me correct it here. No, here some mistake is happening. Is it? So see, some mistake is there. Now we'll do here. So landing point is PB and the highest point is how much here? Highest point is PA. Okay, so it will come here PB minus PA. Is it UB minus UA? So just here the students say UB minus UA will come what here? See, UB minus UA. Is it? So when you will subtract here again, U cos theta I cap will cancel. What will be left here? Minus U sine theta j cap. What will left here, students? Just do here minus U sine theta j cap will left. Okay. So when you will take here the magnitude, because very very important. This magnitude will come what here? When you will take here, it will come here just MU sine theta. Remember that here. Okay. Now let's see the third one. What is given? Change in momentum. Very very important. Between projection and landing point. How much here? Okay. So landing point is PB. Projection point is PO. Okay. So mass is M. And here it will become here UB minus U naught here. Is it? UB minus U naught. Again now we have to do UB minus U naught. So UB minus U naught. What will happen that here? U sine theta will cancel out here. Is it? And no, this U cos theta I cap and this U cos theta I cap will cancel out here. This minus U sine theta j cap, this will also become minus. Okay, so it will become minus 2 U sine theta j cap here. Okay, now correct here. So what will come here? See, M minus 2 U sine theta j cap here. Now because whenever you are taking subtraction, horizontal component of the velocity is always constant. They will always cancel out here. Okay, so what will happen that here? We can write here, see, mod PB minus P naught. It will come here. Remember that, very very important. 2 MU sine theta. Is it? So kindly see very well here. Is it? So first one MU sine theta, second one MU sine theta, but the third one 2 MU sine theta. Is it? Great. Now students, let's see, this question came in J 2008 21, important for NEET also. See, a particle of mass M is projected with velocity U, making an angle of 45 degree with the horizontal. When the particle lands on the level ground, the magnitude of the change in its momentum how much here? Okay, so when it strikes here at point B and projected from point O with velocity, how much velocity? V, making angle theta. Is it? So here they are asking. So if I write here the mod PB minus mod P naught, which case? Third case. What is the formula? 2 MU sine theta. I have told you. So see, 2 M, velocity is V, and here cos, how much angle is given? 45 degrees here. Cos 45, 1 by root 2. So 2 by root 2 means root 2. So answer will come here, root 2 MV. Root 2 MV. Which option is correct here? The correct option is here. Option A is the answer. Is it? Now students, after that, the next question is what say here? An object of mass 10 kg is projected from ground with speed 40 meter per second at an angle of 60 degree with the horizontal. The rate of change of momentum of the object 1 second after the projection in SI unit is how much here, okay? Or we can tell, not rate of change, okay, otherwise it will become, okay, the rate of change of momentum here, okay. Actually, we are going to calculate the change of momentum here, okay? Rate of change of momentum will become force, okay? So, which data is given here? Kindly say very well, students. The mass is given here 10 kg, okay? Speed, projection speed, it is given as how much here? 40 meter per second. Theta, how much is given here? Theta is given here 60 degree here, okay? So here remember that here, you know the formula, force is given by rate of change of momentum, F equal to delta P by delta T. And here they are asking after how much time? They are asking, see, object 1 second after, is it? That means if I talk about the time interval, it is given here 1 second here, is it? So here you know this thing here, if I take here the mod also, is it? So what we can write here, see, now shortcut is there, this change in momentum, sometimes we can write here even F into T also here, is it? Magnitude. Magnitude how much here? At all the points, what will have act? Weight will act, so mg into T. Remember that here, mg into T, or to be more specific, can you write here the delta T? Just delta T you have to calculate. So m how much is given here? 10 g 9.8 times 1 second. So what is coming here? 98 kilogram meter per second. That is the SI unit of the momentum here. Okay, we no need to see where is the particle at which time, whether highest point, landing point, or somewhere in middle. We know the time, and directly we can use this shortcut here. Okay, and see here, anyhow, this is speed how much here? This is speed I have taken here u and projecting with angle theta. Okay, so see the answer. When time is given, directly you can use mg delta t. Is it? Great. Now students, let's see this one. What is the, see, the ratio of kinetic energy. Kinetic energy, which quantity? Scalar quantity. Okay, so see, this is O, highest point. Now I remember A, this is B, this is P, and this is here Q, is it? So see, now we are throwing with speed u, it will hit with speed u. Now velocity is different, direction is different. Here what will happen that here, at highest point only u cos theta, other points not required. So what I write here, if I write here at point O, I will write here speed is u. No need to write vector form because scalar is there. At point A, what is this? U cos theta. Okay, and at point B, what is this? Again u. Is it? So now kinetic energy at point O, so K naught formula you know, half mv square, so half m and u square here, is it? This is the kinetic energy at the projection point here. Okay, now kinetic energy at point A, that means highest point. So what is the kinetic energy at the highest point here? See, half m, and how much is given? U cos theta whole square here, is it? Remember that here, this thing is there. Okay, now see kinetic energy at point B here. So here what will happen that here, see, at point B, it will come here, students, half m u square here, is it? So see, at different points we have written the kinetic energy, is it? Now after that, what we are going to see? We are going to see the ratio of kinetic energy. They used to ask in the exam. So see, ratio of kinetic energy between projection and highest point, how much here? Okay, so projection means K naught and highest point is A, is it? So anyhow, we can write here, see, half m u square, na, projection, highest point, what is given here? See, half m u square cos square theta. Just 1 minute, see. Half m u square cos square theta. Okay, so see, half m u square cos square theta. Half m u square cancel. We can write here 1 by cos square theta. Is it? Now students, after that, if we see next one, see, ratio of kinetic energy between highest point and the landing point. Highest point and landing point. You see, highest point is highest point. Again, see, here mistake is there. Highest point is A. Okay, so we can write here Ka by landing point B. So at the highest point, what is given here? See, half m u square cos square theta. Landing point, half m u square. It will cancel. So what will come here, students? It will come here the cos square theta. This is projection and the highest point and the landing point. Now the third one is the most important. What is this? See, the ratio of kinetic energy between projection and the landing point. So see here, projection is O, landing point is B. What will come? Just think. It will come half mu square. This will also come here. How much here? Half mu square, and it will come here what? 1. 1 by 1, it will come here 1. In the absence of air, now in the absence of air, no conservative force, so kinetic energy will be conserved here. Now here we have to make one table, but for that we should Now one more thing, that is the potential energy. Potential energy is always having some reference. So let's take here, let's take the reference is there at point O and at point B. What is happening? I am taking reference. Potential energy is 0. O is there, B is there. Okay. And let's take if in case at any point height is h. So that time potential energy is given here mgh. Okay. And you should know very well this height is maximum. Okay. This is the maximum height. So where the potential energy is the maximum? At the highest point here. Is it? So based upon that, we have to make here the table. Okay. Now let's see. If I write here points, these points are there: kinetic energy, potential energy, and total energy here. Okay. So what is happening that here, the students, from point O to A. So from point O to A, what is happening that here, speed is keep on decreasing. I told you na, resultant velocity, that is keep on decreasing. So what will happen that here, this kinetic energy will be keep on decreasing, but the height will keep on increase. Okay, mgh. But here what will happen that here, this will be constant in the absence of air. Okay. Now at point A, that means at the highest point, remember that here at the highest point, this kinetic energy will be minimum. Only horizontal component of the velocity, no vertical component of the velocity. But potential energy will be maximum. Okay. And this will be also constant here. Is it? Next one, if I talk about here A to B. A to B, what will happen? The body will go down, velocity and acceleration both in same direction, kinetic energy will increase, potential energy will decrease because height is keep on decreasing, and again constant here, no air resistance. Okay. And at point B, what will be there? At point B, students, this kinetic energy will be how much here? Half mu square. And here how much here? 0. So here also anyhow, this one here, half mu square. Even at all the points, I take here, I take here, I take here. At all the points the same. This half mu square, half mu square, half mu square. Okay, like this it will be there. Okay, remember that here, especially point A, very very important. Okay, great. Now students, let's see this question. No, very good question. See, a ball is projected with energy E at an angle of 60 degree to the horizontal. The kinetic energy of this ball at the highest point of its flight become how much here? So at the projection point, what is the kinetic energy? They have given here E, and what is this? Half mu square. Is it correct? Now students, at the highest point means what we can write here? See, half m u cos theta whole square here. Is it? That means we can write here, see, half m u square and cos square 60. Cos 60, 1 by 2, so 1 by 2 square. This will become E. That means I can write here kinetic energy at point A will be how much here? This will be E by 4 here. Okay. So E by 4, which option is correct here? The correct option is here. Option C is the answer. Is it? Now students, if we'll just see here the last question. What is the last question? See, a stone is projected at angle 30 degree to the horizontal. The ratio of kinetic energy of the stone at point of projection to its kinetic energy at the highest point is how much here? Okay. So remember that here, projection point means K naught, and the highest point what is given here? Highest point is we used to write here Ka. And what is this ratio here? K naught means here half mu square, and the highest point what is given? See, half mu square cos square theta. Half mu square is cancelled. So what is here, students? 1 by cos square theta. So see, 1 by, which angle is given here? 60 degree here, na? 60 or 30? See, 30 is given here. Okay, so cos square 30. Cos 30, what will come here, students? Root 3 by 2. So root 3 by 2 square, it will become here 4 by 3. 4 by 3, where is the 4 by 3? Option B here. Okay, see here. So students, I hope so this video based upon the ground to ground projectile motion and important terms, change in momentum, kinetic energy is very very clear to you. Keep studying, keep growing.